Algebra Brainiacs, welcome to the Johnson Kendro Video Hour.
But it's not an hour.
Alrighty then, we're gonna have fun anyway.
Today it might be.
Yep, this is a long one, so buckle those chin straps. Alright, all about probability today. Probability just means the likelihood that an event will or will not occur. It can be written as a decimal, a fraction, or a percent.
Is that the same as odds?
Odds? What are the odds?
Correct.
It's a little bit different.
Okay.
A little bit different.
Not the same thing.
No.
Alright, there's two types.
Experimental and theoretical. Experimental means the number of times an event occurs over the number of trials. Trials means how many times you do something.
Also, this is the notation for probability of something happening. So capital P and then whatever event you're talking about goes in the parentheses. We're going to use that a lot.
Okay.
Okay, the other type is?
Theoretical, which means the event, it means the number of favorable outcomes. That means how many good ways to do something.
And that should be like what should happen.
And the experimental is what actually does happen when you do an experiment with it.
And they're not always the same, right?
Right.
Okay.
Alright, so let's do an example. Let's flip a coin. Find the theoretical probability of flipping a coin and getting tails.
Okay, so theoretical, we're talking about this.
So number of favorable, how many tails are on a coin?
Well, I didn't think they had tails because they're not an
well,
animal.
the eagle
okay.
is on one side.
Got it. Okay, one.
And then, but how many sides are there?
Two.
Right. Okay. So, 1 out of 2 is 50%. What's the experimental? Let's try 10 flips. Ooh, and looky what we have here.
Yeah, fancy dancy.
Fancy schmancy.
Coin flipper.
All right, you hit start, I'll say stop. All right, we'll do heads and tails.
Oops. Put my marker down.
Stop. Put another heads. Stop. Ooh, there's tail. See, the eagle has a tail. Stop. Another tail. Stop. Oh, stop. All right. Stop. Wow, look at that. Stop. Stop. How many we got? 3, 6, 7, 8. 2 more. Stop. And one more. Stop. All right.
All right. So, how many times did we run the experiment?
10.
And then we considered tails success. So 1, 2, 3, 4, 5,
6.
6.
So
and
not
you should
quite.
always reduce.
Yes. So 3/5 is a little bit higher than 1/2. But that's what happens. So it doesn't always come out perfectly. But if we did this 1,000,000 times,
I bet it would get really close to 1/2.
it gets closer and closer to the theoretical.
What is that called? Something
the law
theory.
Of big numbers.
Big numbers, yes. That's
kind of a fancy name. Well, not really, but. Okay, the next thing. What if you can't run the experiment? What if you can't find a fancy dancy little app?
Yeah, a coin flipper. Okay, so what we're going to do is run a simulation, and we'll explain this a little bit more in class, but your TI-30s and your graphing calculators have a function on there. It's called a random integer generator. It is found in the probability menu, and when we type it in on those TI-30s, it's rand with an I at the end. That means random integer. And what you're going to put in the parentheses are the integers that you want it to start with and comma stop with.
You got to put a comma in there.
Yeah. And we'll show you how to do all that. Okay, so on a multiple choice test, each question has 5 options, but only one is correct. Simulate guessing answers. What is the probability that you will get above 50% on a 10-question test? Holy cow. All right, so what we're going to do is run an experiment of choosing numbers 1 through 5 at random. So I have some hints over there on the side, and what we want to do is define success. So success we're going to call a correct answer, and we're going to let a correct answer represent any random integer. Let's choose 1. Okay? So now what we're going to do is enter in the calculator. Remember, that's in the random integer function, whatever it is called. You put the number you want to start with, which is 1. We want to use numbers 1 through, what do you think?
5.
1 through 5, because those would represent the 5 options on the test. And when we get a number that is a 1, it's considered a correct answer, and when it is any other number, it's considered incorrect.
All right,
Alright.
so let's try it on the calculator.
All right, so I'm logged in here, entered my random integers.
All right,
Here we go.
here we go. First one is 2. Next 1. Next 1. 4. 3. 4. 4. 4. 2.
1, 2, 3, 4.
1. That was the last one, I think.
Okay.
All right.
Okay, so this is a list of 10 random integers that represent guessing on a test. So we want to count the number of successful guesses. Remember, 1 represents a correct answer, so 3 out of 10.
Ooh, that's not 30%.
Right.
All right, so
That means like on a 10-question test, I scored a 30%.
Right.
But that's not answering this question.
right, we need to do this experiment many times to get more results so we can figure out the percentage. So let's pretend that we did this 10 times total. So our first one was 30%. So let's put down some other percentages. Let's pretend we got a 40, 20.
So you're telling me I'd have to actually run this?
Right, we have to do this 9 more times.
Okay.
10, 60, 50, 30, 40, 70. Ooh, good guessing on that one. And 10.
Okay. So we ran our experiment several times.
So now what we do is choose from that new group all those percentages and which ones will it be above 50%.
So if I go through and look, I've got this one. Are we considering 50 success? It says above 50,
no.
so I'm going to
I
say
don't
no.
think so.
Okay. So
And then
2,
2 out of 10.
so that means a 20% chance.
That you'll get above a 50%. All right.
We
So-
can talk more in class about how to run those, but
Yeah, maybe we'll do one together as a group. Or
Yeah,
something. All right, next. Venn diagrams, Mr. Venn.
all right, it's
Swell guy.
It says at Spring Lake High School, 100 students are surveyed at random. Of those students, 40 are taking Spanish, 50 are taking English, and 35 are taking both. Create a Venn diagram to represent the situation. So this big old box is called the sample space, and she's putting 100 at the top because that represents the total number of students in the sample space, whatever population we're talking about.
Yeah, I just like to keep that in mind when I do the Venn diagram. So my first Venn diagram, I'm going to do the Spanish class. And the other Venn diagram, or the other circle of the Venn diagram, I'm going to do English. Okay, now there are 40 taking Spanish, but remember, 35 are taking both. So where they overlap, we have to first put in our 35 to represent both. Now, to get to 40, I need to add 5 more.
Oh, I
So
see.
the 35 and 5 are still in the red circle.
Gotcha.
Okay, and then to get to 50, I need to add 15 more because 35 and 15 is in the green circle.
Can we fill any other numbers in?
Well, if we add all these 3 up, that's 35, 55, I get a 45 that are not in either. So we might need to know that for some statistics.
All right, so that's helpful because we can use this little picture to help us answer some questions. So we want to know what is the probability that a student is taking English. So how many kids are in English?
There are 50 kids in English,
Out of the sample space.
100.
Good. So you can do decimal or percent. We don't care. Do you care?
I don't care.
I don't care.
All right.
We love fractions. Do you think our students love fractions?
No comment.
All right. Spanish and English.
Okay, that's the whole thing, everything together. Both taking both at the same
Correct.
time, though.
Right.
Not either or, it's both for sure. So that would be 35 out of 100.
35%.
Okay. Okay, not taking English. So this you gotta be careful of.
So that's, is it these people?
They're taking English
Oh, yeah, 'cause
and
it's English
Spanish.
bubble. So here,
5 of those and
And-
45 not taking either of them. So that's a total of 50.
wait, I've got a question. There were 50 people that were taking English. So doesn't that, since we had 100 total, isn't that the same as subtracting
Oh,
it?
you could just say opposite of how many are taking English.
That's
that-
called the complement.
It's the complement. There we go. I'll try to give you compliments along the way.
Also, that only works if the events are mutually exclusive, and we're going to talk more about that later on. Not
All right.
today.
Now the
Another day.
next one is Spanish or English.
So that means we're considering this, or these guys,
Yep.
or these guys.
Right.
Okay. So what's that?
55.
55. Is there another way we could come up with that?
Well, the 45 out there by itself who are not taking either, we could subtract from 100
Okay.
and get our 55.
That's handy.
Yeah. So some of it's just common sense logic, and some of it you can use formulas. Ooh, look at that pretty picture.
So that's a dartboard. I made that. It
Nice.
took me like a long time to get all those circles colored in.
I want to give you a compliment for that. That's pretty cool.
All right, use the area of an object to calculate probability. So that's what geometric probability is. We're doing the dartboard in class. You may have some rectangles in your assignment, so just know the area of a rectangle is length times width. So we want to know what's the probability of scoring 5 points. So to do that, we're going to find the area of the 5-point bubble over the total area of the dartboard. And there's some information that's a little cut off down here. It says the radius of the inner circle is 2 inches, and then each ring increases by 2 inches. So it may not be drawn to scale, but I did my best, okay?
It's pretty good.
All right, so where is 5 points?
It's that ring, though. It's not
It's not a circle.
a circle. It's a ring.
Okay, so this is going to be difficult to describe via video. But here's what we're going to do. We're going to find this area of the circle that I'm putting the dotted line around.
Okay.
And then if I were to remove this inner part,
So that whole thing.
right,
Okay. So
So
we gotta
let's-
figure out the radius that goes out to the blue
the blue.
dotted.
So this is 2 inches, we said.
Yep.
Here's 4, 6.
8.
That's 8-inch radius. So to find the blue dotted circle, we would do pi times 8 squared.
Got it.
Then we want to remove the inner circle, which was red. So here's 2 inches, here's 4 inches, 6 inches.
Okay.
So pi times 6 squared. What goes on the bottom?
Well, the total area would be all the way out to the edge.
So 2, 4, 6, 8, 10. I think that I picked everything to be 100 today so that I didn't have to divide.
Nice. That's good.
Okay, now what about these pies? These are freaking me out.
Don't freak out. It's okay.
All right, so we gotta do 8 squared.
64.
So that's
pi.
64 pi. I don't have to multiply that out or
No,
anything?
you'll see what happens
Okay.
here. We'll just leave it.
All right, how about 6 squared?
36 pi.
Over, this is 100 pi on the bottom.
Right.
And those are like terms, like terms on the top. So what's that? 28 pies on the top, 100 on the bottom.
100.
100.
Oh, looky there. The pies cancel out.
Oh, got it. Or,
Nice.
you know what? We could have done heart surgery. Pie heart surgery.
Wow.
That's a new thing. Okay, that'd be 28%.
Very good. Otherwise, you would just divide to figure out your percent.
Let's do another one.
All right.
Let me get rid of all my sketching.
So
here.
score at least 10. So that means we gotta do that whole inner circle, the blue and the white and the little red.
Oh, so no subtracting. We're talking
Right.
about all that
I
stuff.
just want it because it says at least, so that makes it a little bit easier.
All right, so this is cool. 2, 4,
6.
So area of success on the top. 6 squared over the whole area. We actually already figured that out. That's pi times 10 squared, or 100 pi. So this will be 36 pi over 100 pi. or
36%.
cool. Alrighty.
All right, ta-ta for now.